Hello everyone, welcome to Group 12 video about an application of calculus which named Newton's method. This presentation is prepared by Zhou, Lin and Phúc. Stay tuned. Long time ago, 1600, the world was full of rebellions, war, slavery, hunger, and blood. Newton has his own problem too. He wondered, what is the square root of 16.09? Now we have calculator and computer to easily solve the problem, but in 17th century, Newton had nothing. Newton et al. Got here, meaning that aside from Newton's, there are multiple mathematicians involved in solving this problem. In 1664, Newton utilized Vieta methods of perturbations, but no hints on the derivative, just polynomials. In 1690, Rabson improved the method to avoid tedious computations, but it was not yet simple enough to understand and derive. So until 1740, Simpson introduced derivative and his approach is quite close to our present one. So what is the idea of Newton's method? We will go through the concept of this method right now. Newton's methods approximate the solution of an equation fx equals 0, which is also called root finding algorithm. This is the root we want to find, but how to approximate this root exactly? Let's say we have an initial guess x0. We draw the tangent line of fx at x equals x0. The slope of this line is equal to the f prime x0. Extend the tangent line until it intersects the x-axis. And this is the next guess for the root x1. Iterative the process until you get an acceptable solution. By doing this multiple times, we will approach the root. And say hello to the Newton's methods. This concept introduced us to the formula to calculate the next guess. Xn plus 1 equals xn minus fx over derivative of xn. The proof of this formula recall the point slope tangent line equations to the curve y equal fx, or the linear approximation of fx and x equal a. Let's xn equal a. Note that the tangent line cuts the x-axis. We have this following transformation. If this is too fast for you, feel free to pause the video and read the proof. Let's see. Can we apply this method to find the square root of 16.09? We already know that the square root of 16 is 4, so it's reasonable to set our initial guess with x0 equal 4. Apply the formula, we can compute the next guess, x1, equal to 4.01125. Note that we want to find x so that fx equals 0. Let's compute fx1. It's near to 0, but we are greedy, so we compute x2 using the same formula. Now, fx2 is so close to 0, we accept this result as the solution of the square root of 16.09. So in general, what we are doing here is turn from 0 to 0. The closer to 0 fx is, the more the precision of the solutions. But this is for most of the cases. In math, which is a hypothetical model, we have to be aware of the limitations. For root finding, we seek the roots of fx, but for optimization, we seek the roots of f prime x. So to find the absolute extreme of a continuous function f, we need to find the critical points of f, or in other words, the points where f prime is equal to 0. That is why for an optimization problem, we need to seek the root of f prime x. So in this graph, you can see we want to find a solution for the red curve and the blue curve of f prime x. At f prime x equals 0, fx is at the extrema. You want a step-by-step solution, but you are at the end of Calculus 101, so we believe that you can all do it by yourself. In math, we have to be aware of the limitation in the method we use because we do not want error or wrong result. Therefore, sometimes in certain cases, Newton methods just doesn't work. The first limitations that we encounter by choosing a bad initial guess. For this graph, we want to approach the blue route, but being a bad decision maker, you choose the wrong place to start your journey. Another scenario, during the iterations, your tangent line might get stuck in a stationary point, then the derivative will equal 0, then your method will return math error. The next problem we may encounter is the discontinuous derivative. meaning that every time we take the revisions, it will turn back the first one. And then we can never reach the root because we're trapped in its loop. Kind of rhyme, huh? But not everyone win the lottery, but everyone can find the root of any equations by using the Newton's method. If you stuck, don't give up. Try it again. Thank you for listening.